section 14.2 is about permutations and combinations. Permutation is basically an arrangement where the order or the placement of something is important. In your book, example 1 on page 760, it says a manager of a coffee shop needs to hire 2 employees, one to work at the counter and one to work at the drive-through window. Katie, Bob, Alicia, and Jeremiah all applied for the job. How many possible ways are there for the manager to place the applicants? You can see below that example in your book on page 760, you can see the tree diagram drawn out for you. Okay, now understand, like where it says outcomes, KB is different from BK because you've got the counter and you've got the drive-through. So there's order here. So those are 2 different groupings, if you will. So BK and KB is not the same thing. So you see very quickly that there's 12 different ways that you can have 4 applicants take 2 positions. That is what we call a permutation. We might not want to draw out a tree diagram every time. And so what we can do is a symbolism that's called the permutation of 4 things taken 2 at a time. There is an equation for the permutation. This is like the format that you're going to use. This is the permutation of n things taken r at a time, and it's equal to n factorial over n minus r factorial. Okay? So when I'm talking about, let's say, 4 things 2 at a time, I'm going to go, that's the same as saying 4 factorial over 4 minus 2 factorial. Well, remember what the factorial means. 4 times 3 times 2 times 1. 4 minus 2 is 2, so 2 factorial is 2 times 1. So that's equal to 1 and that's equal to 1. So the only thing I have to worry about is that 12. So that is the permutation of 4 things taken 2 at a time. Let's do one that's not with a word problem. Let's say we have the permutation of 10 things taken 6 at a time. That is the same as saying 10 factorial, because it's this first thing factorial, and then I'm going to subtract 10 minus 6, this minus this, factorial. If I write it out, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and on the bottom I have 4 factorial, which is 4 times 3 times 2 times 1. So these last 4 I don't need to worry about. So I'm going to use my calculator and I'm going to multiply all those together and I'm going to get 151,200. So how many different ways can I take 10 things 6 at a time where order is important? So it's a permutation. 151,200. Let's look at another example. Look at example number 3 in your book. This is on page 761. Example number 3 says, the word processing program requires a user to enter a 7-digit registration code made up of digits 1, 2, 4, 5, 6, 7, and 9. Each number has to be used and no number can be used more than once. Well, that means I'm going to choose from the 7 items 7 things at a time, okay? When it's that way, on the top I have 7 factorial and on the bottom I would have 0 factorial, and at first we want to think that that's undefined. The 0 factorial is actually equal to 1. So that is the same thing as going 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives me 5,040 possible ways that you can arrange those numbers in a 7-digit registration code. Okay, now, so that's my total number. But what if they go on to ask what the probability that the first 3 numbers are even? Okay, so now I'm looking at probability, first 3 even. Now you know probability is success over total. So there's my total on the bottom. Okay, that's the total number of ways that I can arrange it. Well, if you go back and look at the numbers, you have the number 1, 2, 4, 5, 6, 7, and 9. And I want to know the probability of even numbers. So that's an even number, that's an even number, and that's an even number. So basically, I'm looking for successes here. I need one more space. So I have 3 choices for the first, because remember I want them even, okay? 3 choices for the first, 2 for the second, and 1 for the third, because these 3 I want to be even numbers. Well, now I've used all the even, so then I have 1, 2, 3, 4 possibilities for the 4th thing, then 3, then 2, then 1. So when I do that, that's going to be 6 right here. This is going to be 12 times 2, well, 24. So 6 times 24 is going to give me 144. So I have 144 over 5,040. Now I want to reduce that to lowest terms, or I could just go ahead and divide the bottom into the top, okay, and get a decimal value and change it into a percent. You can do it either way. If I reduce it, it reduces to 1 over 35. If I just want to make a decimal out of it, I'm going to take 144 divided by 5,040, and I'm going to get 0.028. I want to make it into a percent, so I'm going to round it to 3%, because remember I have to move my decimal 2 places to the right. All right, let's do another one here. All right, Shaquille has a 5-digit passcode to access his email. Okay. The code is made up of even digits, 2, 4, 6, 8, and 0. Each digit can only be used once. Okay, so here's my 5 digits. 1, 2, 3, 5. And here's all my choices. 2, 4, 6, 8, and 0. So that is the permutation of 5 things taken 5 at a time, okay, which is the same thing as 5 factorial. So 5, 4, 3, 2, and 1. If I do that out, I'm going to get 120 total possible ways to arrange that. Okay, so on the bottom of my probability, okay, which is going to be my next thing. So that's going to be my first answer if it just asked me for the number of total ways. You could do it out on this because there's 5, then there's 4, then there's 3, then there's 2, then there's 1. Okay, so that's going to be my total possible outcomes. I'll multiply all those together. Okay, but then my next part of the question asks me for the probability that the first 2 digits of his code are greater than 5. So here's my spaces. I know my total is 120. I've got to figure out my success. Well, my success says I'm going to be successful if the first 2 digits are greater than 5. Okay, well those are the only 2 that are greater than 5, so I have 2 choices there. And if I choose 6 there, then I just have 1 choice there. I would have to put the 8 there. Then I have 3 choices for those. 3, 2, and 1. So that's 6 times 2, that's 12. So my probability is 12 over 120, or 1 over 10. Or it's going to give me 10%, if you will, because that's going to be decimal 10, which is 10%. All right. Now, arrangements that don't include order. Okay, you're just like putting your hand in a place and pulling it out. You don't care what order you pull it out in. It's just random, if you will. Those are combinations. So permutations involve order or arrangement. This is no order. Okay, and let's talk about an example. Well, let's first talk, okay. We call this a C, and there's a formula for this as well. The combination of n things taken r at a time is n factorial over n minus r factorial times r factorial. This part is the same as the permutations. The times r factorial on the bottom changes it. So let's say that we have, we're going to choose 4 students that can eat free pizza. And we're going to choose it from a group of 7 students. So that's a combination of 7 things taken 4 at a time. This is the total number of students I have. That's going to be how many are being selected. There's no order here. You're just pulling 4 students to be able to do this. They're not sitting in an order. They're not standing in an order. Okay, they're just being selected. So this is 7 factorial over 7 minus 4, or 3 factorial times 4 factorial. Okay, so let's do this out. So I have 7, 6, 5, 4, 3, 2, 1 over 3 times 2 times 1 times 4 times 3 times 2 times 1. Okay, so mark. I don't have to deal with those. 3 times 2 is the same as 6, so I'm going to mark those 2 out. It's going to give me an answer of 35. That's how many different ways I can select 4 students from a group of 7 students. All right, let's do another example out of your book. All right, customers are at Tony's Pizzeria and they can choose 4 out of 12 toppings for each pizza for no extra charge. How many different combinations of pizza topping can be chosen? So there's no order here, I'm just choosing topics. And I'm choosing from 12, I'm choosing 4. So it's a combination of 12 things taken 4 at a time. So remember, the top is 12 factorial. The bottom is the difference there, which is 8 factorial, times the r part. So I have that going on. So 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then times 4 times 3 times 2 times 1. All right, I'm going to go from here down. All right, so what I'm left with is this on the bottom. So I can, if I want, 4 times 3 is 12, so I can mark those out. And 2 goes into 10 5 times. So I'm going to multiply 11 times 5 times 9, and I'm going to get 495. So that's the number of ways that you can choose 4 toppings from 12 toppings. All right, let's do a couple here where they just give you the combinations. Let's say I want the combination of 16 things taken 12 at a time. You should be able to do that out, pause the video and come back. You can use a calculator. 16 factorial on the top, 4 factorial, because the difference between those, times 12 factorial. Well, I know here I've got 16 times 15 times 14 times, I missed 14, times 13, and then it would be times 12 factorial, which on the bottom, remember I have 12 factorial, okay, because I just didn't want to write it all out, so that'll work, okay, so now I've got 16 times 15 times 14 times 13, and on the bottom I have 4 times 3 times 2. So if you did that out, you're going to get, and again, use your calculator. If you want to put it all in there at one time, make sure you put parentheses around that, and it's going to give me 1,820 ways that 16 things, you can choose 12 things from 16 things. All right, that actually is the start of example 5 on page 763. It says a science teacher at Sunnydale High School needs to choose 12 students out of 16 to serve as peer tutors. A group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be tutors. The first part says, how many ways can a teacher choose 12 students? Okay, so there's a number of ways that a teacher can choose 12 students. All right, so I'm going to put that up here. That's going to be my total, okay, because the next part's going to be probability. And it says, if the students are chosen randomly, what is the probability that 4 seniors, 4 juniors, and 4 sophomores will be selected? Okay, that is the 4 seniors. If you go back and look at the problem, there are 7 seniors, so it's a combination of 7 things taken 4 at a time. And then juniors is a combination of 5 things taken 4 at a time, because there's 5 juniors. And then sophomores is a combination of 4 things taken 4 at a time. That right there, that number, is what's going to go on top of that 1,820. So you're going to have to do those out. And when you do those out, you're going to find that that first one is 35. The second one is 5. That's what the combination of 5 things taken 4 at a time. And the last one is 1, okay? Because you got 4 factorial on the top and 4 factorial on the bottom, if you will. All right, and it's over 1,820. Use your calculator there. You're going to find out that that's equal to 175 over 1,820, which is going to give me decimal 10 or 10%. The probability of choosing 4 seniors, 4 juniors, and 4 sophomores is 10%. Let's do another one similar to this. And this has to do with money. Okay. Diane has a bag full of coins. She has 10 pennies, 6 nickels, 4 dimes, and 2 quarters. Okay, the first part of this says how many different ways can she select 4 coins. Okay, now that's going to be my total. That's the number of ways. So this is the combination. I need to find out how many I have. Let's see, that would be 20, 22. So it would be 22 things taken 4 at a time. So, whoops, hold on one second. Let me check and make sure the video is still working while I'm doing this. Okay. All right, 22 things taken 4 at a time. Let's see, so on the top, I have 22 factorial. On the bottom, the difference between those two is 18 factorial, and then times 4 factorial, okay? So on the top, if you will, you're going to have 22 times 21 times 20 times 19. But then when I get to 18, it's going to cancel out with a factorial on the bottom.